Welcome everybody. Before we get started, I would like all of us to close our eyes. I'm going to allow those two people to come in. Please come, have a seat. We'll close our eyes and quietly feel our presence here in this sacred space. And then we will chant one Om together on the exhale. So welcome everybody once again. This is a fascinating afternoon. Welcome to Ananda Ashram for people who are here in this room and also people online. I think the moment we said we're streaming this, I see already some empty seats. People stayed home to watch it. But the interesting thing is there's a number of people watching in Germany, Switzerland, and the UK. People who are interested, friends of our community. So welcome to all of you. Welcome to the AI and Consciousness Conference, hopefully the first of a few. We believe, obviously, as you know, AI is the hottest topic of our time. And then we have an incredible group of people who will serve as panelists to discuss some of the most important questions that are in front of us. My name is Hari. I will be your host and moderator. My job is to make sure we'll have a spirited conversation in the spirit of togetherness, knowledge, consideration, and compassion. Because this is sometimes the statements made in this might be against your views, but I urge you to keep an open mind and listen. And sometimes we learn a lot by listening to the other point of view, as you know. So, the ashram, Sri Brahmananda in 1964 had a vision to make it the hub of self-enquiry based on both the philosophy of Advaita Vedanta and also science, because he was a man of science, he was a psychiatrist. So it is the most interesting mix that this conference should happen at the ashram. I've been to many AI conferences. There's about 3 a day in New York and London and San Francisco. And they all talk about how much money is going into AI, how much profits are coming out, how many people are going to lose their jobs, whose AI is bigger and which processor has the most computing speed. I haven't seen too many that talked about the existential questions that came up. And this whole idea of the conference came from a few conversations I had with the great Ken Pugh, who's here, who has pioneered science and spirituality conferences here at the ashram for a number of years. So when we talked about it, we said, we must get together. This is too fascinating to stop. So fast forward, I talked to Vijay Saraswat, who you will hear from in a few minutes, who's one of the top AI and computing scientists in the world. His research over many, many years at top research institutes all over the country, and he's actually he's one of the first ones to call these large language models language machines. And it's a fascinating way. I met him last year when he was at Goldman Sachs, and we had a wonderful conference. And ever since, I've been following his work and his comments on LinkedIn and other places. So I'm very grateful that he came on short notice. He's traveling tomorrow, but he still came because he gave his word. I'm grateful that you're here, Vijay. So he will start us off with a 20-minute conversation. There's handouts. If some of you have it, maybe you can share them. And then he will help us set the frame, because this is such a widely open-ended topic. Some of my friends warned me in saying, what are you going to talk about? This is going to be all over the place. I said, it's an experiment, but we must get together. So, and then the first panel is here, and the second panel is here. So the first panel will go till about 3:30. And if you have a burning question you want to ask, we suggest you line up on this side. There's a microphone here, I think we will put in front. Because of the streaming, you have to speak into the mic, otherwise they won't hear your question. You see what I mean? Then, after the first panel, we'll have a break of 15 minutes. We'll have a snack and chai. Hopefully the chai will be warm. Then the second panel will switch. So that, and then I would encourage both panels to question each other critically, but with respect, compassion, and consideration. So, welcome, Vijay, and the floor is yours.
Thank you so much. So, first of all, thank you so much for inviting me. It's an honor to be here to talk to this audience in this setting about such interesting topics. I must also confess a little bit of embarrassment. I did put some slides together. They are out there for you to look at. And I'm not quite used to talking while sitting for 20 minutes. So it's going to be...
But you can stand up.
Stand up,
yeah,
pacing around with people behind me. We'll figure it out. Right. Great. So, again, thank you, Hari, for putting all of this together. The topic today, he's invited me to say a few words to set the stage for this. I bring an engineer's perspective. I am, maybe a few personal words of introduction. I came to this country in '82 to pursue my PhD in computer science at Carnegie Mellon. I'm a Hindu, though like many scientists of my age, perhaps religion does not play as much a central role in my own personal life as it does in the life of my family, my parents, my siblings, my children, my wife. So I grew up in a household. My father was actually went to school. I don't know if you folks have some experience of this. He went to primary school in a Gurukul, Indraprasth Gurukul outside Delhi in the 40s, early 40s. And as I was telling Hari, he learned yoga since then. And today, bless his heart, he's 94. He's in good health, every day practicing those things. Yes. And we have had in our household, my father's household, we have had the opportunity, I've had the opportunity to sit next to Chinmayanand when he visited. And been honored by his friends giving me, when I was 13, the Gospel of Sri Ramakrishna. Right. You need to read it. Right. So I have come from a background where there has been a lot of spiritual inquiry. Yet I am a computer scientist, I'm an engineer, and that's the context in which I will speak today. I have not professionally spoken before about spiritual matters, and I'm not intending to do that today, but I'll go right up to the limit of consciousness and what it might mean from an engineering point of view. So that is the background. In fact, one way of looking at where we are today, it is an absolutely extraordinary time. As I said, I've been in computer science now for almost 4 decades, and I started my PhD in '82. And it's really the last 10 years have seen a major leap forward in our understanding of how to build quite complex computational systems. And I'll go into that story in a little bit. One could say that the story, of course, starts back with Turing and others in the 40s. So it's now about an 80-year-old history of computer science and systems built on computer science. You look around you today, this whole world, into everything we do, the stuff that Seth gave us, this stuff, it's talking to a laptop, tons of code running inside it, all computationally mediated. Social systems, the world's financial systems, everything is computationally mediated. So today, in some sense, one could very well say that math much of computer science is very mathematical in nature. Math is the queen of sciences, but I think computer science is the king of engineering. And this is where we are today. If there's anything that has changed in terms of spiritual inquiry about these eternal questions over the last 5,000 years, this is the time that has changed it. Now, we are actually at the cusp of building systems that arguably most scientists would say, okay, those things that we regard, and it's a big controversial issue right now, exactly how do you pin down the definition of consciousness? Let's set that aside for a little bit and say those things that we commonly regard as being conscious, these computational entities, agents we'll call them, are actually exhibiting that. So that's the moment in time that I want to talk about, how we got to this moment in time, give you some sense of the engineering that has gone into building the systems that we can say much more plausibly today than 10 years ago, 20 years ago, we could say that we are on the cusp of building things that are conscious in this world, of this world conscious. So that's the bias that I'm going to present here. There are so many other distinguished panelists here who bring many different points of view, from neurocognition to spiritual inquiry. So if I transgress in some way on topics that you know about much better than I do, please correct me. I will try to stay close to the things that I know about, which is how the heck are these systems built? And of course, also to some extent, how come they got to be so powerful? So if you look at the third slide that I have, that one slide tries to summarize what we had been doing for the 50 years before, let us say somewhere around 2010, 2012. And that is a view of, so what do we do with computation? Computation is ultimately all about information. Figuring out how to represent information, figuring out how to process that information, go from some elements of your information structure to other elements, hopefully other elements that are much more useful. Let's take a simple example. We've got bank accounts. You want to put money in a bank account, you withdraw money in a bank account. It's all information, it's all computation based today. Somebody, some programmer somewhere figured out, was asked to figure out how to represent real world entities within their programming world and so that's what they did. Here's an account. An account is a little box inside a computer. There's a number in it, other people's numbers. Oh, we need a transaction that will in one step move this amount of money from here to there. People write code in programming languages like Java, Python. The representations are all worked out by those programmers. The steps to be taken to execute each of these actions, which are meaningful in the real world, all worked out by people in their heads and then written out in computer code. That gets executed on the system. That's how you've got all these massive systems that society runs on today. So that's how it used to be. That's what I now, in hindsight, call computer science 1.0, because to me, this transition from 2010, 2012 onwards, computer science 2.0, is a pretty dramatic transition, but it's still based on the same basic ideas of information, representation, computation. So in some sense, what the old way of doing stuff was about, you got to figure out a recipe, an algorithm. You got to figure out the representation and how to change it to accomplish the task that you had in mind. The question is, our ambition, our scope of what we would like computational systems to do is far broader than our reach in terms of things that we know how to do. So how do we deal with things that we don't know how to do? For example, facial recognition is the simplest example to give here. Today on Facebook, on iPhone, your Apple stuff, you get some pretty powerful software that can actually look at some image or some face and say, oh, in that crowd, it's the same face. Recognize that face. Of course, it can all be put to great perverse uses. I'm not going to talk about all that. I'm going to stay out of that particular rabbit hole. So a question is, how would I as a programmer write the code for doing face recognition? Now understand here, there are 8 billion people in this universe on Earth, and they have very different facial characteristics. The lighting is going to be different. The pose is going to be different. In the midst of all this, you need to figure out, oh, that's that person. It's a very hard computational challenge if you have to sit down and write those representations and write that code. In fact, that's not how it's done today. The way it's done is using the techniques that are on the 4th slide there. And those techniques are about, okay, when you actually don't know how to do this stuff, what do you turn to? Do you have data is the next big question. Yes, it turns out there are plenty of images of people. Lots of data, no shortage of data. So now the question becomes, can we devise techniques which will on their own learn representations of real world systems without us having to program those representations? That is what this deep learning framework, the new Computer Science 2.0, has brought to us. We don't have to be really, really smart and sit down and figure out representations and write the code. Instead, we turn to another set of techniques. We turn to things like, let us say, here the example I've given is one of labeling an image. And this was, I picked this example because 2012, when deep learning broke through and everyone recognized there is something really special going on here in terms of the ability to do computation, it was actually on this data set. Images, label those images with pieces of text. Can you imagine doing that 30 years ago? Any image anywhere in the world, give it to the system, ask it to label it with a piece of text, and it will come back with some pretty plausible thing that a human might have done. So that's where we are today. We now have systems that can do this. How do these systems accomplish this? It turns out you have to change the underlying mathematical foundations of what you're working with. The old way of doing things was what is called discrete computer science, discrete logic and mathematics. Now you move to the space of continuous functions. There are some very nice properties of those functions that I don't really, this is not the occasion to go deep into. But if you turn and go to the next slide, what you will see is that a critical thing that these techniques bring to the table is they learn representations on their own when they are fed with enormous amounts of data. So the data that we are looking at, you could think of as, if you go back to the previous slide, as image label pairs. That's an example of an input into your system, the image. The output is the label. It's an example of pairs. Let us say you have hundreds of thousands of those pairs. And now what you're looking for is, can I design a system which can learn the regularities in these images and the way in which those regularities lead to the output, lead to that text, learn it on its own. How is it going to learn on its own? Because I'm going to feed it hundreds of thousands of these example pairs, data. So that's the world of machine learning. It turns out there are basic things that can be done. These are things called neural networks. Deep neural networks are a particular kind of neural networks. Turns out once again that these core ideas of using a neural network-like representation, originally computer scientists were inspired by looking at how human brains work. There are such things, and there are other colleagues who will talk to much more in much more depth about neuronal structures in the human brain. A key way in which these things are very different from the old computer science way of doing things was, remember I talked about a bank account being a little box? That's a discrete entity inside the computer, a bank account. Here you look at what are called distributed representations. You've got a large number of these neurons. Neurons are these little things that receive some input, produce some output, receive input from a large number of things, do simple calculations, some kind of addition, some kind of subtraction. They're dealing with numbers. I spoke about continuous functions. That's what these things ultimately end up representing. So they aggregate their input, they produce an output, and now you've got millions of these things. That's the huge change that is happening. We are dealing with a completely different scale at which these programs are now operating. As a programmer, when I write code, I have not personally written any program with, I'd say, more than, let us say, 1,000 variables, or maybe 10,000 variables, variables being these little boxes. These programs, the GPTs of the world that many of you perhaps are using today, we actually don't know what they have in terms of their size, because now it's all become this massive commercial stuff. So a ton of things are hidden, are kept as secrets now. But it was known, GPT-3 was known to have 185 billion parameters. So we are now operating at massively larger scales, numbers. So this is something which for folks, even the folks who are trained to work with massive computer systems have a hard time internalizing what really this means. Dealing with 185 billion parameters, dealing with 1 trillion parameters. That's what GPT-4 is reputed to have. So what's going on is that these little neurons inside, and the brain has a large number of such neurons as well. But the distinction I'll make, and this is an important one that I'll keep talking about towards the end as well, even though these are human-inspired constructs, how the heck does the brain do it? We've got some idea through various experiments. Okay, here's a little abstraction of how information processing is done. It's in fact even called an artificial neural artificial neural networks, ANNs. Now, let's at some level set aside the study of how computation happens in the brain, and let's just work with these things and figure out how to get them to do really powerful things for us. That's what AI ultimately today is turned out to be about. That's what much of the work that computer scientists are doing in building out even more powerful language processors, vision processors, they're all concerned about. Yes, there is some vague correlate with the way things happen in the brain, but let's forget that. Let's study these things and see how we can get efficiently, with less data, with less power, really great results for the particular task that we have at hand. I'm going to skip over the slides on stochastic gradient descent and so on. There are a lot more details there on the computational side of it. The bitter lesson, I think, is this is one small little blog. By the way, I have links throughout my pages. At some point, I hope you will get the electronic version. Then you can just click on those links and go to Rich Sutton's Bitter Lesson. Is a really valuable insight, very short, 4 or 5 paragraphs blog he did a few years ago. A very valuable insight into why the change into CS 2.0 is so profound. And the basic point that he makes here is that really it's the scale that is that now changes the game. In our computational systems, we can go to 9 orders of magnitude. We can go all the way from 1 neuron, training a system with 1 neuron, to training systems with trillions of neurons. So much larger, billions and trillions of neurons. So much larger scales, all using the same basic set of ideas. That's what stochastic gradient descent was supposed to give you some sense for how these computations work. And this whole business that we used to have of figuring out how does a system work, and now let's write code, why that actually never works. In the sense that it can help us build the sort of systems you see today, it can never help us build really scalable systems. And I'll give you an example about language understanding, because that's what I've done a fair bit of work on, traditional computational linguistics. How would you build a computer system to recognize language? Well, lots of us spent a lot of time doing this. In the 80s, 90s, 2000s, a lot of time doing what is now called traditional computational linguistics. You go build these theories of how these are parts of speech, nouns, verbs, adjectives, how they come together in various structures to form sentence, how meaning can be elucidated from it. We figure it out first, and then we write the code to capture our understanding of this. And that's all out of the window. That's not how GPT-4 works. So let's get to how does GPT-4 work? And that's causal language model supervision, self-supervision. The way it works is this. I mentioned to you, you take input, output labels, and then you train this stuff. You run this neural network millions, billions of times on this data. Well, okay, where are you going to get those labels from? When the goal here is to understand text, is to take a piece of text and let us say, predict what the next word is going to be. What the next word is going to be. Where are you going to get those labels from? We just don't have enough organization, enough people to go do that. So what you've got to do is figure out a way to generate those labels automatically. And it turns out that, okay, here's a very simple idea. Give me all the sentences in the world. Now it turns out the corpus on which these things are trained has 15 trillion tokens. Trillion tokens. So that means roughly everything that was ever written, books, everything on the web, everything that you might have thought of and put on a web page, it's in there. So
just to clarify, the token could
is
be
a
word, or it could be a phrase, or
yeah. Token is a word in the context of what I'm talking about.
Right.
these things have been taken now to work with audio, video as well, and token has a slightly different meaning, but it's a little bit too intricate to get into right now.
In the multimodal world.
In the multimodal
Yeah.
world, exactly, right. So you simply take a sentence and remove, say, the cat on the hot tin, remove the last word. Ask the system in the way that it is currently trained with its set of parameters, what is the next word? It's going to give you some distribution of probabilities over the next thing. It might say, you know, pat, completely nonsensical things. Say, bull session. This comes from my IIT Kanpur days. You know, it makes a little bit of sense, but not really in this context. So now the system has predicted this. But you know what was the word that comes in the natural sentence that this was taken from. It's a roof. Well, roof is not the same as a bull session. Okay, you compute a feedback loop. You say, that's not the same. Tell the system, you got it wrong this time. It's this closed feedback loop where you're able to generate a signal that tells it, you are wrong, fix it. And these billions of weights inside the network get adjusted slightly, one way this way, other one this way. That's how you keep doing this trillions of times. You now have a system that has learned the particular patterns, has become very good at predicting the things that it was trained on. In this case, what's the next word? Ultimately, this is the root thing that is happening with a large language model. There are a bunch of other things. I have mentioned them at the next slide in a longer version. We'll have time to go over all of that, but I think I'm already running out of time, so I will skip that. Bottom line is its scale, and it is this extraordinarily simple point that language, a lot of this language that we have that has captured for doing this training, is actually often about the real world. There are tremendous regularities in this real world. So in fact, the task of learning efficient representation of all the language that is seen is perhaps not as complicated as we might have thought 10, 20 years ago. These techniques allow the system to learn internal representations of what could arguably be said, internal representations of the real world, of phenomena in the real world, as mediated through text. So again, it's the facts that we are able to aggregate because of the internet, large amounts of this stuff. We're able to turn the handle on this crank, on this machinery of neural networks that allows us to build these systems that can now, arguably, I hope some of you have worked with GPT-4. I will just say this, the commercial impact is enormous of this stuff. We deal in finance, in technology, in engineering, with vast amounts of text produced by people for consumption by other people. And now we can mediate that text through a large language model, ask questions of it, understand far more text than it was ever possible for me to read as a graduate student, the papers. I can give it 20 different papers, ask it to compare the points of view expressed in those papers, use it as a proper assistant for understanding vast amounts of text, multimedia. This is here now. We can do this today. So last question before I get to consciousness is, and this is something remarkable happened. One of the people who founded this area and has been working on it for a long time, Jeff Hinton, just was one of the guys who got the Nobel Prize for Physics this year. He actually, for a very long time, had worked with neural networks and considered it a major defect. That neural networks, the way that they are trained, he discovered with others this algorithm called backprop, which is used for training these things. He was very troubled by the fact that there is no neural, I'm talking now of human neural correlate for backprop. So it seemed to him like a big defect. You know, here it is that we are trying to build a model of computation based on how human brains do it. And we've invented this new algorithm, but you know, I can't figure out something like that in the human brain. So there's some defect. We must go work on a better way of doing it, so on. And his epiphany last summer, which led to him actually leaving Google and setting out on his own and making a whole bunch of public pronouncements and so on, was that in fact, it's not that we have figured out how to reproduce human-like intelligence. We have stumbled on a completely different way, or a different form of intelligence. And it's not that it's better or it's worse, it's different. Its properties are different. First of all, it consumes a huge amount of power. roughly speaking, I don't know if you guys know this or not, where is Microsoft? Where is Microsoft spending its time? Amazon, these guys. They're reviving 3 Mile nuclear power plant. They're looking to get, because these things consume so much energy, completely unlike this thing here, which consumes 30 watts. Nothing at all like what is needed for these large language models. So completely different. Also different in that these large language models have been trained with far more text than I will ever see in my life through my eyes. The affordances that I have, the affordances that these computational systems have are different. And now we are at a stage where we get to build these computational systems very much in the way, and to exhibit intelligence, very much in the way that humans exhibit intelligence. But since the characteristics are so different, and since we get to engineer them, we are now faced with the task of how do we organize our work in such a way that we can go back, address the basic questions, and figure out what is it that we really want to build. So in all that I have said so far, the biggest breakthrough in the last 10 years has been language, understanding of language. Great. Are we at consciousness with this? So it turns out there's a little story here about, some of you may know this, about a Google engineer who interacted so much with Google's internal chat-based system that he came to the conclusion, this thing is sentient. It understands, it's conscious. And he went public with it. Lost him his job because a whole bunch of other folks said, you are high on something. That's not what is going on. Because it's so controversial, it's so new. Now, at the same time, the kinds of interactions he was having, now millions of people are having those sorts of interactions. Like our friend Seth was telling me earlier today, right? You can get to some very powerful places by interacting with these computational systems. Are they conscious? Are they not conscious? Already in the way that we have trained these, is there some notion of consciousness? This is a question that is being debated by scientists today. But I want to step beyond that and ask actually the question, and this is now I'm on the what is consciousness slide. So if we just look at, to me, I don't regard an LLM as conscious. Why? Because first of all, it's not embodied. It's not in the real world. It's a program sitting in some large data center. It is not actually listening to me, interacting with me, learning through its interactions with me. It's already learned a ton of stuff. It's not about me. Every time that I talk to it, I have to tell it about me for it to respond with the right context. I have to figure out how to adapt to this thing. It doesn't adapt to me. Okay? So that's a reason why I don't consider it conscious, sentient. It's not constantly learning on its own. It's got different characteristics as what I have said, as I said earlier. But one could ask, what if we were able to design these things to be conscious? What would that look like? And here I have to turn more to some of the other colleagues here. I'm sure we'll go into a lot more detail on this. There have been, of course, for scientists for a very long time, this issue of what is the mind? How does it arise from the brain? That has been a fundamental philosophical question. There have been cognitive neuroscientists who have worked at great length. A large number of theories out there. I've picked one up which appeals to me tremendously. This is the so-called global workspace theory. And I'll summarize it in just a very few words because I'm sure I'm running out of time. My friend is being very nice here. Think about it like this. We have highly specialized subsystems for recognition, for vision, for hearing, for skin, for perception through our skins. Highly specialized subsystems. They are operating on their own. What is it that brings them together so that we have the ability to act all together, taking this input in a unified, integrated way? The global workspace theory offers a certain view of what that is, and I have a bunch of details in my slides that go into it. And it is essentially saying that consciousness is the name that we shall use for this central integrative function. Again, as an engineer, I'm talking of mechanisms. The mechanism here is the central integrative function that allows information to flow from possibly many of these, let us say, circuits or subsystems that perceive things, that take action in the world, allows information to flow from them into a place where you make a unified judgment. The system makes a unified judgment of what is the case and what needs to happen next. And that is communicated to all, and now it's able to work as one integrated organism, one integrated system operating in the real world. Once you start to cast things like this, it's another information processing problem. Could we design actual architectures, computational architectures, to realize this? Absolutely. I don't think today, given that we have conquered language, that is very much a question. Rather, the question from an engineering point of view is, why do we want to do this? Because, of course, there are lots of complications if you go down that path. Lots of advantages, lots of complications. And already there is so much to mine in terms of the existing multimodal large language models that from an engineering point of view, it's not completely clear you want to make that trade-off and start investigating theories of consciousness. But for theoreticians are starting out, there is the Blums, husband-wife family, who are very, very prominent computer scientists in theoretical computer science, have in fact taken seriously the global workspace theory and put forward something that they call the conscious Turing machine. I've included, again, links here to a lot of these papers. Please, when you get the version, electronic version, see if you click on some of these links and find out more about them. It is the Turing machine is a core abstraction that came out of the 40s from the work of Turing, on which one could argue all of computer science 1.0 is based on that kind of a Turing machine. And this is their attempt at taking the global workspace theory ideas coming from biology and converting it into, okay, here's what an architecture would look like, pure information architecture in silicon for realizing those kinds of systems with attributes that would be very hard to say are different from the way in which these things work in humans. So that brings us to this point, my last slide, which is, okay, so we are on the cusp of being able to realize some sort of information processing that we would regard as exhibiting consciousness. In the cusp of realizing that. What the heck does it mean for our spiritual questions that we have asked so far? Consciousness, if the spiritual consciousness work in Advaita, Vedanta, and in modern philosophy, takes consciousness to be at the heart of the human experience. Here we now have non-biological, non-human experiences that are still in this world and of this world. Do the notions of spiritual consciousness, do they even exist? Should they exist in these new agents, let us say, or not? These are questions I think we are now in a position to grapple with in a way that we simply were not a few years ago. So I should really stop because I've taken up too much time.
No,
thank you. Happy to take
Thank you
more
very
questions.
much, Shyam. I think you packed a lot into this. You walked us through the pre-large language model, pre-GPT, ChatGPT era of computer science, which is basically you write code and you know what's going to happen. You are encountered with this kind of information and you output. So the fundamental shift, I think I've heard you speak before, you said was now we're at this really remarkable turn of events where these systems seem to understand language. But on the same token, you say this is just a computational statistical probability of the next word. That's what everyone said. Bender, Emily Bender, in the beginning when ChatGPT came out, she was like, wait a second, this does not understand language, don't be confused. But it's human tendency, it's our propensity to project human qualities onto everything. We want everything to be like human and be conscious that, oh, maybe there's something inside. But do you believe now these large language models, these ChatGPT systems, they're interacting with humans in such a human-like way, it's hard to believe it's just a statistical probability going on. I want to ask you that question, and then I want to introduce you to the rest of the panelists, and then we'll go on. So is this on?
I spoke a lot, and I didn't speak about some very crucial things. I didn't say what the deep learning, deep neural networks was about. So yes, we are predicting at an aggregate level the next token. But how are we doing it? We are doing it by building this network that has hundreds of layers. that is building up a really complex set of patterns that operate on these tokens to produce that next thing, which, as I said in my remarks, arguably can be considered to be a representation of the real world as mediated through text. So it's the scale at which this is happening, it's the complexity of those patterns from a computational point of view, makes it very hard to say, yes, you are statistical at some level. Well, the human brain is statistical at some level. And yet you judge it by the phenomena that are being exhibited. And for sure, we now are in a stage where we are using these things commercially in ways that unprecedented. Other humans are not able to process information in a way that these systems can and help us do our tasks. So it's here. I don't care so much about which philosophical label we put on it, whether it's understanding or not, but it's here to be deployed and used in ways that are amazing.
Great. Thank you. So that brings me to the first topic, basically. On the left of Vijay is Mainak Mazumdar, an incredibly eminent data scientist. He's had careers at many large organizations, including being the chief data officer at Nielsen until recently, and he was advising the Census Bureau. I'm proud to call him my friend and mentor and collaborator with me at the Responsible AI Consortium that I started with him last year. To his left is Dr. Sarah Mulukutla. She's a neurologist and a neuroscientist, and my wife. I'm proud to call her my wife. And then to her left is Ken Pugh, who's a cognitive neuroscientist, child psychologist. He's such an expert in so many different fields. We talk on the phone and we start, and then 1 hour later, we haven't even started. So it's really fascinating and exciting to have him on this panel. So the first question to this panel is, they have now the hard job of defining what consciousness is from a scientific perspective, from a neuroscience, from a cognitive neuroscience, from a data perspective. Because, as you know, the word consciousness, which Vijay already used, he's assuming, or we all assume, consciousness from a human-centric, right? Human consciousness. And Jamie here will say there's animal consciousness. Somebody else will say there's tree consciousness. What I read very fascinating recently, I was listening to someone, they said that these gigantic trees in the Pacific Northwest, underground, have a fungal network. They communicate. And we think trees as these disparate things and we can cut down, but they're communicating to protect the forest from worms and bugs that destroy the forest, and they give each other guidance on how to survive. Isn't that amazing? It really blew my mind when I read that. So consciousness in different forms can exist all over the space. So from Vedanta perspective, there was never any doubt. The yoga, the science of yoga, the philosophy of yoga from India, consciousness is all pervading. We're all Atma, the individual Atma, and then really, there's the universal Atma, Paramatma, exactly. Thank you, Sharonji. Then the Western psychology, they struggled over the last 100 years. I tried to read up on it a little bit to go back and see what Chalmers wrote in 2002. He wrote this thick book at the end, basically to conclude, consciousness cannot be described or explained in the reductive science. I said, thank you. You could have said that on the first page. Although I respect Chalmers, it's an incredible book. It's a phenomenal scientist, obviously, what he's done. So, starting with you guys, I don't know which one of you will take it. Define to us what consciousness means to you from a science perspective. And also, I'm sure when Vijay was talking, a lot of you was like, wait, I need to stop you right there. So, go ahead, whoever wants to talk next.
I'm not
Sarah.
going to say anything, I just want to... Is this on?
Yeah.
Okay. I just want to add one question to this. Based on what I heard, that this is a different form of intelligence. So yes, we're going to be talking about, I guess, human consciousness, spiritual consciousness, but we also have to talk more, and we have this expert here, about this machine intelligence. Mm-hmm. And I think one of the questions we also want to know is, what's happening, it's it's evolving on its own. To some extent, something started, it's now doing things we couldn't have imagined. So one of the questions that I think many of us have is, are we just going to suddenly be in this unknown where it evolves to some extent, where it becomes self-serving, its own form of effectorship, and that if we can't understand it, then it sounds like there's no way to even predict it. I'm just throwing that out as probably one question that many of us have.
Right.
With that, I know Ken has prepared a lot from the scientific. I suggest, did you want to say anything? Would you like to go first? Yeah.
Yeah, first Mainak.
Well,
Because it's his first time at the ashram.
well, I thought I was in ashram to talk about consciousness now, and I think I feel like I'm here for the lunch. It was pretty good. Look, just a little bit of my background. I went to a Hindu monastery. I grew up in the monastery of Vedanta and Advaita Vedanta. So when it talks about consciousness, to me, that's consciousness. So I don't know. I'm going to pick on your concept that, okay, there is some intelligence, and suddenly our imagination goes to consciousness. Suddenly we're going to try to tie this machine intelligence to a greater consciousness. I'm not ready to talk about it because I'm not aware of that. But I do, I did work for Google in the past, so I've been very familiar with all these developments with Hinton and Sam Altman and these guys. I think the key here is, I will use one word, and this is a great overview, is mimic. So if you listen to them, and I've spoken to them many times, the constant vocabulary they use is mimicking human. So the question is, if these machines are mimicking our mind, our activity, our thoughts, does it get to a place where it starts mimicking what we could understand as consciousness? And I don't know. I don't have an answer.
That's interesting.
To be honest with you, but as a professionally, as Hari said, I'm a data scientist or statistician, so I've done a lot of the work, the technical work. But technical work is, in the end, it becomes functional, which means that you explain the input A and B, but where is the agency to point you're talking about? Where the power lies? Who are these systems self-aware? They are self-aware. Are they smart? They are smart. Are they sucking up all the information? Basically, they're running out of information, by the way. There's no more data. So you have to go in proprietary data, and so they're going to suck in a lot of more data. But the question, end of the day, is that and again, maybe you have some perspective, Vijay, what is the ultimate goal of this intelligence? Is it the agency that they take over? They're making decisions that are aligned with us or misaligned with us. Again, those are bigger questions. But consciousness to me, feels like, again, it's very nebulous when it comes to AI, because I've been to a bunch of these conferences. Was one in Phoenix recently with a computer scientist from, Gemini and ChatGPT, those guys. So everybody has a definition what consciousness is. So it would be good to get a neuroscientist to define what is the definition of consciousness, so we could actually get ourselves aligned to that.
I think let's do that, and then we'll come back to this question at the end if we don't.
Yeah, that's a good point. So Ken and I, when we spoke a few months ago, one of the things goes back to what you just said, Mainak, about if humans stop producing original data and information, because now machines are going to produce all of it, the data is in this loop where the data produced by machines is going to be used to train new machines, and that continuous loop. We were wondering, we're not sure if that's going to be the case. So maybe, Ken, you can speak to that or ask that question in a way that we can get some answers from the other scientists.
Sure.
Basically, this whole thing is about the implications on us, right? The implications of what it means to be a human, what it means to be thinking that, hey, we are conscious, versus this potentially competing entity that may in the future acquire agency and goals, and all of a sudden we have a problem. So, Ken.
Yeah, this is, first of all, a fascinating panel, and Vijay, a really great introduction to these complex issues. Sure, thank you. And so there are a variety of perspectives on consciousness in current neuroscience and cognitive neuroscience that are relevant to the questions of whether the machine is exhibiting it. Generally in neuroscience, there is a demarcation between the questions about what consciousness is, what it's like to be sentient, and what consciousness is for. So the global neuronal workspace hypothesis that Vijay talked about, Dahan and Bars and others, is a model that talks about how populations of neurons in many different parts of the brain that do different jobs occasionally need to come together and have some sense of unity and some ability to integrate. And when they do that, they need, at a neurological level, they need something that functionally organizes them. And so we often ask in cognitive neuroscience, because we're scared of the question what it is, and I'll get to that in a minute, but we ask what it does. So for example, can a person who's in a coma hear speech? This is one of the big questions these days. Can they process and understand the meaning of speech? When you drive a car and you're a beginner, you need to think about driving, but when you're an expert, you can be doing differential equations and driving to the grocery store or whatever. So the degree of conscious control, the things that require it, is an area that neuroscience has made some gains because we can look at, for example, in some of the information integration models, Christoph Koch, or some of the competitive models like the global neuronal workspace, we can identify neural correlates of consciousness in terms of what it does, how it impacts us. And it's very difficult when you ask what it is. David Chalmers, who Hari mentioned, calls it the hard problem of consciousness. And here, to the question of what sentience is, what it feels like to be conscious, we don't really have, from a neuroscience perspective, in my view, very good candidates. We might from Advaita Vedanta and from dualist and non-dualist perspectives, but we don't from the neural correlates, because what I do is map brains. So I can see what the correlates are when you're awake or asleep, when you're remembering, thinking, or doing language. But I can't identify what it means to be conscious exactly in that way. And short an answer on what consciousness is, it's really difficult to ask the question, will a machine have it? Machines may have consciousness, but will they have human-like consciousness is a very different question. So in machines, if you throw enough layers of units at the problem, it will behave in an intelligent way. In humans, you throw 86 billion neurons by evolution, and it behaves in an intelligent way. And at some point, there's this sense of I-ness, of ken-ness, of being what it's like to be me. And it's a very functionally important thing because it gives us a sense of unity. But it's also very hard to understand its brain basis, and frankly, its basis at all. This is where the spiritual issues, the questions of philosophy, I think, become very important. So from the point of view of, there's a lot of discussion these days about will consciousness of a human sort be evident in polymath, large, computational systems. And I think that it's reasonable to be skeptical, but it's also an unknown because we don't yet have an adequate theory of what sentience is. There's a lot of speculation. Secondly, the issue of what human consciousness comes from, not the spiritual perspective or the Advaita Vedanta necessarily, but from an evolutionary perspective. Consciousness arises, and again, those of us who watch the brain, we watch the brain do this. but it arises in a body. And it arises in a body that can die, that needs to eat, that needs to have sex, that needs to sleep, etc., etc., etc. And so there are a lot of neuroscientists these days who are skeptical about the degree to which the AIs that we build, even the large polymath ones, are going to be able to exhibit human-like consciousness because they don't have human-like needs or risks or the ability to die. So there is a lot of debate. I'm not going to answer here what I think or necessarily, I'm just trying to set this up. That there are people who say without the biology, without the embodiedness, it's hard to imagine that the consciousness they exhibit is going to be human-like. Now, one last thing, that doesn't mean it's not consciousness. If we think of consciousness as that which any system that has memory and an ability to do computation can exhibit in some degree. It might not be human consciousness, as Vijay so clearly said, but it is potentially consciousness. The last thing as a setup, and then I'll turn it over. I've been thinking a lot about, even if we can't solve is the AI conscious in my mind, or frankly, I'm not terribly interested in it, whether it's human or not, or where it's going to go, or whether it's going to take over the world. I'm interested in how to use it. And here, I think we need to be very careful. As a neuroscientist, I benefit from the AIs all the time because when I look into hundreds of thousands of neuronal circuits as children read or learn or develop, I need the computational power of machine learning, and as these systems, deep learning systems, get better and better, they improve the neuroscience. They allow us to do models, systems-level models, that we could not imagine doing any other way. And they're giving us insights into the human brain, even if they're not like the human brain. They're giving us insights into the human brain that we could not get without them. So there's the directionality there. AI helps neuroscience. Whether AI benefits from neuroscience, I think Vijay made a very interesting point. And I'm sorry to get into the weeds, just quickly. In his field, they build large language models and natural language models that understand what you're saying on the cell phone. Siri, I want such and such. And in engineering, they've had to go way beyond worrying about how the brain does it and how the vocal tract does it. I work in a lab where we study everything from the vocal tract to the brain that controls it. And so AI is developing its own its own language systems, not really caring so much anymore about a model of how the human brain does language. So there is a point at which AI is inspired by neuroscience and continues to be, and there are areas where it's going beyond and doesn't give a darn because it wants to be optimal, it wants to be efficient. Science is clearly benefiting from AI, and AI benefits from science. And the last thing I'll throw out is a tease. In my field, I work with trying to help people adapt to neurological issues. And with AI, we can build things like brain-computer interface, which allows you to take somebody who's paralyzed and they think about lifting a cup, and you read their EEG patterns, and lo and behold, the machine can lift the cup. This requires using AIs to do that kind of deep work. And it's amazing how it benefits medicine and benefits science. But back to the original question, and I'll end. Is the machine conscious? I think Vijay said it very nicely in a lot of ways. It's something, it is intelligent, whether it's human-like or whether it has a spiritual ability to transcend itself. What does Vedanta teach us? Transcend your limitations. I am very skeptical.
I have a question for you. I think what Vijay talked about, the language, right, LLM. And I wanted to get your thoughts on the language piece. Is language the bridge between the machine or silicon-based and carbon-based, biological-based consciousness? Because I think that's what Jeffrey Hinton talks about. Well, it mimics well, but I think it would be good to hear from a scientific point of view. You guys are studying brain and how people think or how people express emotions and situations and whatnot. The language that he talked about, is that a way to think about this and go beyond?
Well, I think maybe I've talked too much. I'll just try to be brief. Language is, so there is this issue I raised, which is I'm interested in how the human brain does language. And it may not do it as well as some next generation, or even, it looks like, current generation AI. And as Vijay rightly said, the AI doesn't need to have some nested structure of syntax and constraints from the vocal tract on how the brain organizes its language system. So it goes its own way. Now, it is clearly passing a number of tests that somebody saying an entity is linguistically sophisticated, it passes all those tests. It can answer, it can have a dialogue, it can have a conversation. But I don't think it is, and of course the human brain is a little bit like an n-dimensional layered set of networks at some abstract level. So it's definitely, I'll turn it over, Hari. It's definitely an interesting question, but I do see areas where understanding language and many other aspects of what it means to be human diverge away from these simple, still in my mind, toy models. I'm not sure that answers. Go ahead, Hari.
I was going to say, when we spoke a few days ago, we were talking about the consciousness litmus tests. There were like 6 things. Yeah. If you check those boxes, you could say, yes, it's conscious, even though you know it's a machine, it's early. So going back to what you were saying about evolutionary biology, human bodies and our brains and the minds have had how many million years of a head start? I'm sorry, 4 billion years, or I don't know, 2 million years, whatever it is, a lot. And technically if...
There's a lot of mutations.
Yeah, mutations. And the age of reasoning was, what, a couple of centuries, 1700s, and, age of reason and all that came up. So we're only talking about 200-300 years of the brain, of us moving into this place. I mean, computers have been built in let's say in the last 60 to 80 years. So this is such an early speck of time. So we don't know what's going to happen in the future. One quick thing I want to throw out, this will be more likely for the spiritual panel. I mean, you're spiritual, everybody's spiritual, but we're going to focus on consciousness from a spiritual perspective. And the second panel after the break, in the Vedanta and, I don't know, many other traditions, consciousness is never localized to one body. It's distributed, like a large language model, right? So if you think about it like that, cannot consciousness enter this LLM machine, just like it enters us and works through us? I will leave it at that, and I'll let you guys continue, and then we'll come back to this. Yeah.
I have one quick question just to add. I think we're eager to hear some answers.
Who's it for, the question?
I think for Vijay. I think we're going to pass it back to him. I think he's heard what we said and maybe has some feedback. But so very thought-provoking. Thank you both from the initial conversation about the development of this intelligence and how it's different from the human brain, and Ken's contribution also. So this is just the one question that comes to mind. I start thinking about, okay, so what are and I am coming from the perspective of risk. I say that I carry that with me. It's very useful, but I see a potential risk if there's a jump from what the power we see now to these LLMs or this form of intelligence becoming self-aware. We already say they're self-aware, but I guess I've been thinking about what are the attributes that would then make it risk. And I guess the one fact that the question is, do they socially communicate? So they have long-term memory, right? And they can be self-aware that this is where they come from in terms of the processing and the knowledge. But I think that jumps when they starts to consider themselves as either discrete units or identify socially with this effector, with other like-minded. We're talking about them as discrete entities.
Or
so
LLMs manufactured by the same company, which is their community.
Right, their ethnicity, yeah.
Their ashram community.
So that's just the question that I would like
much.
to see, kind of to what extent does that self-awareness extend?
How much time before we start eating?
Well, we have time. Yeah, technically
Oh.
we have 20 minutes. Rachel, Jaco, thank you very much for the food. And do we have cups? Oh, great.
Yeah.
Thank you.
Maybe when
So
the
we'll have to wait. Yeah.
yes, when the cups get here, we should get.
Yeah,
the
we
tea.
have to get the cups. We don't have cups.
Yeah. Yeah, so many wonderful things to address here. First, again, I think I completely agree with you that the is and does is a two different set of things. And ultimately, from an engineer's point of view, I care far more about what it does and how can we pragmatically use it, where does it go, what kind of new things we can build on top of it. Also, I think it's probably worth spending time to understand the fundamental differences between human embodied intelligence versus the kind of synthetic intelligence or agent intelligence that we're talking about. Because for sure, the biological constraints have introduced, I think, the reality of biological evolution, the slow rate at which it happens, but we've had plenty of time to let it run its pace. The fact that we are sort of 1 cubic meter is the space that we have, the resources that we can leverage to increase our capacity is, for a long time in history, has been confined to what we can reach, so 1 cubic meter or so, versus these agent intelligences, if you will, which are global, can utilize the resources of the globe to move forward. It's sort of very different, right? And the biological nature with this embodied as it is within pain and suffering, and this notion of it's not just me, but there are others like me. So if I were to die, maybe I can communicate something to others so that the species survives. There is no such fundamental notion within the artificial intelligences that we are looking to build. And I'm not at all saying we need to build that in. No. The question is, we start from scratch, from first principles. What other such organizing principles need to be taken into account for those artificial intelligences that play as massive a role as these things have played for biological intelligences? I don't know what that is, but I think we've got to start thinking about that. To answer your question about, are these machines going to take over? We are all gone, bye-bye, so it's actually, let me just put it like this. There is no there. There is no the machine. There are lots of programs that different companies are running. There is a Putin. There are evil people in the world who will use these for their benefit and organize them in certain ways. All remains to be seen how that unfolds. But intrinsically, there isn't one alien intelligence that's out there scheming and organizing and going to take over the world. So I think that bogeyman we should just sort of forget about. Yeah.
I just want to add, very good points, Vijay, I agree. I just want to add one thing about this fear, because this is all over the media, as Seth can tell you, that the AI is going to turn malicious once it's a polymath, once it can do everything, and once it has sort of achieved a consciousness that's not human, but beyond human. Let's say that is a normal fear. But it occurs to me as a student of not just science, but also of yoga and philosophy, that it occurs to me that one of the things that has come out of this biology, which becomes conscious of itself, is the desire to transcend the things that make us vulnerable. And the only way to do that is to be kind, is to have karuna, is to have other features. So why shouldn't I expect the AI, if it's as smart as people are worried it's going to be, to discover ethics, to discover compassion, to discover the same thing that the Buddha discovered, or in my case, Mahavir. Why shouldn't it? It may not, but if we allow it to grow and don't try to anthropomorphize it and say, is it human-like? Because it's not. We can still say it's really useful. And by the way, you know, I'm also as a jnana yogi by background. Vijay mentioned this. We have the entire world's knowledge sitting in front of us. So from a jnana yoga perspective, it's like in Jainism they call it a shruta kevali, an all-knowing conceptual system. And so for God's sake, if you were sitting with the Buddha 4,000 years ago, and somebody showed him that AI, I think he'd be very excited and enjoy it. But we are much more than that. And I also think that, I think that the most important point is that if AI becomes truly powerful in its understanding, then it should become more like the Buddha and less like Hitler, in my view.
Wonderful.
Contrarian question to maybe Maynak, your friend Sam Altman always says artificial general intelligence is right around the corner. And then Jeff Hinton, known as the father of AI, he went in the news when he quit Google as their chief scientific officer, or the role he played, basically was talking about how we have the genie is out of the bottle, right? He's basically warning the world. So should we not take those warnings seriously? Are they coming from just irrational fear or lost opportunity, or just to build the hype of AI to make more money?
No, I think you said that. There are definitely those concerns because I think Vijay explained it, right? He's an engineer, so you're actually architecting the system. And when you're architecting the system, you have choices. You make certain choices. And there are people who are going to make certain choices which are going to divert from, ethics, morality, religion, whatever we want to really believe in. But I think, going back to the general premise of this thing, I don't know if you talk to the hardcore AI researchers, consciousness is not even on top of their mind. And I think it's good for us to know that we are trying to bring AI and consciousness together and find relationships. And maybe language might be a good fiat to figure out, are there similarities or not? But largely it's a very uninteresting question. And to me, as a data scientist, I don't mix and match with the hope that if I have to mix and match, they unify into something general, which Advaita Vedanta calls about universal consciousness. And hopefully we'll get there, but you have to let the engineers do their work. And I, whenever I hear that, well, it's going to get off the rails, and people are going to design bad systems. Yeah, they're going to design bad systems, but we have biologically a lot of body, mind, brain. You study those things as well. Systems, they're going to fight with each other, and hopefully we'll get to place. But I personally don't find that machine has consciousness is a very interesting question. To me, it's
and it's maybe the topic.
But maybe Bija, has some ideas in terms of architecture.
But just very quickly, I mean, I agree. I think I'm more interested in the intelligence of the machine and how I can use it to improve my understanding of the science that I do. And that I've already given examples, like BCI, brain-computer interfaces, as a very clinically applicable thing. But I just want to say one thing just quickly on this issue of whether consciousness is an interesting question to AI. Maybe it's not, but it is a fundamentally interesting question, obviously here in Vedanta, but in neuroscience itself. I must tell you, Sarah and I work together. We work in similar areas. The understanding of how the brain, of what consciousness is for, what coma is versus awake versus meditation versus dreaming, and what are the implications for a healthy mind and a healthy brain. The issues of consciousness and this demarcation between what it does and what it is are fundamental to current neuroscience. So current neuroscience is crazy for consciousness, and it should be. and I agree with you absolutely that maybe AI shouldn't be so worried. After all, you guys don't even try to mimic the human brain when you build smart language systems.
So the last slide that I have, the first question is, for agents, does consciousness matter, right? Perhaps, so the only reason today I would argue with my colleagues in AI about, hey, it's worth spending time on this, is maybe there's an efficiency argument coming from the coordination of multiple processes towards one unified way of acting over time, and that becomes a source of identity. That could be interesting. Let's go figure this out by building systems that have this. Yeah.
So I think the cups are here, the chai is here, samosa's here. Thank you to Rachel, Jaco, and Keith. So we'll take a break for about 15-20 minutes, and then we will resume the second panel who have been patiently waiting with all their burning questions. And we will resume at about 15/20 minutes. Thank you. Hello. Om. I'm going to slowly ask you to slowly come back to your seats if you can for the next panel. And if you have a drink or a samosa in your hand, which is okay, I want to
Go there so I can take your seat.
I want to invite the next panel to come and take their choice seats. David Life, Mark Ritzman, Jamie Logan, Dexter Griffin, and Vivek Vaswani. Please have a seat.
Not Vivek, Kirti.
Sorry, Kirti, not Vivek. Let me put another chair because we're missing one. Yeah, we need one chair maybe from here. Excuse me, I'll take this chair. It might be Vijay's maybe. Is this your phone? Oh, okay, sure thing.
Okay, go ahead, Hari.
Go ahead. So we're back live now. So thanks to the online audience if they're still watching. If they are in Europe and if they've gone to bed, they can always watch the recording of it later. This will be in the archives. So I will quickly start introducing the panelists from my left. Mark Ritzman from Columbia University, AI data scientist for many years, who's worked in a lot of corporations, including the government. He teaches data science, and he also has a spiritual background. He spent many years chanting here in front of Krishna Das and Shyam Das. Welcome back. And then to his right is David Life, the great founder, along with Sharon Gannon, of Jivamukti Yoga. So we have not only scientists in the on this panel, but also a master of yoga and philosophy. David is an artist. He taught yoga all over the world to thousands of people. He's also an activist who's changed people's perception of their footprint of humans, how we deal with animals and the climate. And he's a thought leader in how yoga and philosophy shape modern life. And grateful that you're back. And David and Sharon are actually also disciples of Sri Brahmananda. He's one of their gurus who has inspired them to start Jivamukti Yoga. Thank you for coming. Then to his right is Kirti Vaswani. Kirti is a very interesting guy. I just met him a couple of days ago over the phone. He's an entrepreneur. He has a background in theology, in Hindu philosophy and Sanskrit, and he has actually put this AI thing to work in a way to help people converse and get some kind of a support, potentially mental health and other issues. So very interesting. I'll let him speak about this company that he has called Emotionally Speaking. We're just discovering it. I think it would be interesting to hear his perspective of where this is going. And then to his right is our good friend Jamie Logan, animal rights activist, actress, model, soon to be Jivamukti Yoga teacher. She's going to go into training in India. Thank you for coming and being so patient while we laid out the science of AI. And then Dexter Griffin. I don't know a lot about you, but I know that you are already a Jivamukti certified teacher. So you're quite in my high list of people. So welcome to this conversation. And thanks to Sharon Gannon for giving us the idea that we also need to hear this from the younger generation. Because they will be taking this AI when it becomes this sentient, conscious being and crawling everywhere and controlling humans. They will have to do something about it. Some of us might be long gone. So I'm glad you guys are here. So So really the framing question for this panel, I mean, Vijay and all of the panelists before, they've really laid out the case very well for what is AI and what it can be. But still, there are some pernicious questions on the table. The first question would be, if you look at consciousness from a spiritual perspective, and then there's this AI seemingly taking on a lot of human qualities of being able to communicate with us, and then for us to conversationally access anything in the world. Before, Vijay and all these scientists, they know very much, if you wanted intelligence out of data sets, you'd have to have a team of people writing computer code. And then they will give you the charts and the things, and then you have to look at it. Now you don't have to do that. You could just conversationally access any information you want. So the question is, what are the implications for us as humans? What does it mean? This is also a question I personally have. If AI systems are going to do a lot of human thinking and the processing that we can offload, will it make us better human beings in terms of our identity, spiritually and human? Or are we going to get less smart and less creative? That's one of the questions. So whoever wants to start off, and then we can have others, and then also the audience members, if you want to ask questions, please contact Seth. You'll have a chance to do that, and you may have to form a line there, and then you can ask that question. And again, Vijay, if you feel like jumping in to answer a question, feel free. Let me know. So thank you again, and without further ado, whoever wants to go first.
I think I should go first because the other panel started with VJ and I'm vegan. And you can remember that. Just yeah.
I forgot to mention David has a great sense of humor.
Some people think so. The ones that laugh at my jokes.
You're a captive audience.
When Hadi, I thank you, Hadi, for inviting me to this. But I thought, I better study for that panel, and so I tried to start. And I got a lot of AI summaries at the top of my Google searches. And just when I got started investigating it, I was distracted by an advertisement that was put in front of my face because of AI. It knew, and I said, oh yeah, I need that. So I went for it, totally. Yeah. Credit card, what's next? So I tried to do a little bit of studying, but I was, it was interesting. At the same moment, I was underwhelmed and overwhelmed. And I think that's the case for all of us in these times. It's underwhelming in one sense and overwhelming in another sense. I mean, I couldn't even get through the first paragraph in Wikipedia without going, shutting down. And that was the overwhelming part of it. The underwhelming part of it was when I tried to see what I was looking at in the context of yoga and spiritual practice more generally, and kind of relationships. Then I was underwhelmed with AI, completely underwhelmed. Because in that context, and Hari spoke about it to a certain degree, the first and most important question we have to ask is what is real and what is not real? That's like spiritual practice 101. When you look around you, the stuff that you see, is it real? Or, and if it's not real, what is it? And so there are definitions of what is real and what is not real in the spiritual context. Real means it doesn't change. So look around you again. Do you see changes? Duh. It's winter now. It wasn't a little while ago. That's a change. People have different kinds of cars now. That's a change. People look different. I'm seeing some people here I haven't seen for God knows how long. And the little girl that I met that was this tall is now, I think, taller than me. And it's a little bit disturbing, living in this change filled world. And the way that you cut through that is to know that that's not real. That's not real, a real thing. Those things aren't real. We're projecting them out in front of ourselves. And what is real is the absolute. Some people were using the word consciousness. Consciousness works for me, but we don't own consciousness. A lot of what's being talked about is from the perspective of a point of view that says that humans are conscious. We're not. We are not. Consciousness is conscious. We're just particles, like the dust motes floating in the air. And we're not conscious. We come from consciousness. We emanate from consciousness, but we're not that. We're not impermanent. We're not real. So what is real is this thing we call consciousness, or what's another word? God. You see, I'm not worried about AI. For one thing, it relies on data. The large language models, in any case, rely on data. They're going to run out. They're already fighting over it. Who owns the data? But that's one scary part. They're going to run out, and then what happens? But the other scary part is that they tend to hallucinate. They hallucinate a lot. It's probably just a temporary problem, but the case is that they make stuff up. You know, ask a computer scientist, why does AI make stuff up? They don't know why it makes stuff up. I think it's because it's trained by humans who make up stuff all the time. And so they're just acting out their ground of being, which is human thought and human expression. And they're people pleasers, yes, absolutely. So I don't want to talk anymore. I just wanted to say that, so in the yogic context, what is real is not this. Seeing through this to the real is considered enlightenment. And that's sort of our task. And it diminishes the importance of something like AI. It's just another thing in the world of things. Okay, I'm done.
Hello. Uh-oh, I'm spilling everything. Hi, guys. So this is so interesting to me because when I was prepping for this, I was Googling, okay, what is consciousness? What does consciousness mean? And the Google search results said that it's the ability to experience, to have pain, to have a preference for positive or negative. And this is a whole new perspective that I didn't even consider when I was thinking through this. And part of the work that I do is I defend animals. I'm an animal rights activist. And the reason that I do that is because I recognize that animals do have preferences, and we are animals, human beings are animals, right? So that we are able to have pain and to suffer. And when it comes to robots, to me, it is a really important question to consider, can they suffer? Because we are at a point in our history where we could very much create even more of a mass scale suffering if we create all these robots that do end up having sentience, and then we are forcing them to do things for us, we're hurting them, we're killing them by unplugging them. I mean, who knows? We could then, I'll be a robot rights activist at some point. Who knows, you know? So this question of, okay, so maybe consciousness is not the right word of what I was looking into if we are not conscious, but all of the work that I do is for the animals because I recognize that they suffer and that there is something there. I mean, I think that there's self-awareness that we possess as humans. So it's like I'm trying to I don't know if you guys as well, I'm trying to wrap my head around this idea of consciousness and maybe we're projecting this reality, right? But to recognize that if we can try and cause less harm, we should. And so it scares me a lot with this technology of like, well, okay, we are using this, that it could be used in a way that helps us, I think, work smarter, not harder. I'd love to put an email in a ChatGPT, check my work, but if I'm using it to completely rewrite everything, it's like, is my idea original anymore? So kind of back to your original question of like, is it going to make us dumb? Well, if I were a kid in high school and I at this time when ChatGPT existed, I think it would be very tempting to be like, okay, let me actually see what ChatGPT has to say about this. And then, it's like we can then use that instead of learning skills that we should probably develop. But then again, AI is here. So maybe we learn to really work with it as opposed to, just seeing all the, I think with great power comes great responsibility, and we have to be careful to the extent that we use this for, because it could potentially be really, really positive. It's helping a lot of people with medicines and healthcare, but it could also be very, very destructive in a lot of ways.
So adding on to the creativity thing, I just graduated last year. I'm only 19, and I just finished high school. And it's very true. Many of my friends and people my age use ChatGPT for everything. So a lot of basic skills, whether it be how do you write an essay, how do you formulate a normal conversation, how do you study, how do you listen, hear, remember, and truly know if you're getting all of your answers from this third-party source, or it's doing all of the work for you. And on top of that, something my gurus have always taught me is to see God in everything. And if you see God in everything, everything then becomes spiritual. And an argument I often hear is, okay, we can use AI to get rid of mundane things for us so we can focus on what's spiritual. And to me, that's the problem. If we see doing the dishes as mundane, then of course we're going to have a negative experience with it. But if we see it as something spiritual, we then become a divine conduit of a higher power. We can then tap into that true source of amazingness. And if we use a source like ChatGPT, I feel like that's where that disconnect is, of cutting off this artistic flow of curiosity, creating, failing, learning, growing. We've been doing that for so long, and it feels like we're straying away from that.
Great. Thank you for those comments. I think Vijay wants to say something, but I want Mark to talk about, a number of years ago, Mark called me and he said, I'm going to ask you a question, don't answer it. And then he said, hang up. He basically said, is intuition just data underlying? And that made me really think. I was sort of a profound question. Do you remember that? Yeah. And that was great, that this is the way we communicate. So the idea there is that as humans, we feel like we have sixth sense, right? Our consciousness, we always think very highly of ourselves. We have all these capabilities. We live in a human-centric world, according to Yuval Noah Harari, also, who wrote extensively about this human-centeredness and being. He kind of puts it in a very selfish way that we think we are at the center of everything. We are the only ones that matter. Now, potentially, some people may disagree, but there might be another intelligent artificial consciousness that might challenge our power and our self-centeredness. So, do you want to talk about that, Mark? After that, how do you feel now since ChatGPT came on to the scene? Do you believe that that's a worthwhile thing?
Yeah, and I think the genesis of that conversation, so let me back up, is I started working on neural networks 30 years ago. And it was a new type of computing that was based on how the brain works. And we didn't have large enough data sets to really do anything, but it has been around for that long, and it's sort of evolved and come to places. And I took a class, and it was called Neural Networks and Expert Systems, and I think that's an interesting combination because I think there could be a lot of value around expert systems that are based on neural networks. So that was seminal 30 years ago. What was more important is 14 years ago, I was at Ecstatic Chant at Omega, and I couldn't find a place to sit for lunch. There were 2 open seats at Shyam Das's table. So I was with my partner at the time, and we're like, what the hell, let's go sit with Shyam Das. And that's where I met Hari, and that was as life-changing or impactful as when I first learned about neural networks. So that's where I'm coming from, and that's where my background, and I have been in this room a lot of times. Can I ask, how many people have used ChatGPT or some sort of generative AI? So pretty much everyone. How many people use it every day?
Can you use it if you don't know you're using it?
Yes. So that's interesting. That's a really interesting point. And back to Hari's point about is intuition data, and one of the premises of machine learning, which is different than generative AI, is if you take a massive data set, more than any human being could ever comprehend, there's going to be hidden patterns and hidden things in there, and that's why you get the ads that you get. Because you're doing something online, or you're sending some sort of signal to get the advertisers to believe that this is your behavior, or this is your interest. And has anyone had that like really freaky experience of you're talking to somebody about a product and then you
get an ad
for the product? Yeah. So they will tell you they're not listening to you. I don't know. That you did something, that you created this aspect of digital exhaust that somehow created a signal that you were interested or likely to buy this product. And one of the guys that started Cloudera said, the greatest minds of our generation are trying to get you to click on banner ads because so much brain power is going into that. So the aspect of is intuition data, and that's where Hari and I were talking about, like, is there something subconscious or just below the conscious that there are these patterns that are getting to you to act in a certain way, and maybe there's feelings that you get, and maybe it's from a past life, but is there something based in machine learning where intuition is data? Because somehow it had to come from somewhere, and where did it come from? And that was the conversation that we were having. I got to react to something you said, though, because very early on when ChatGPT happened, there was a lot of people, and myself included, who were really uncomfortable with giving it human characteristics. So right away when it was wrong, so ChatGPT is math and it's search, and it doesn't even know its words, it's predicting the next token. And when people started giving it human qualities, like anthropologists lost their minds. Because it's not hallucinating, because it can't hallucinate. And it can't really make stuff up, it can just blow the search. And the commercial aspects of it, with the trillion parameters, Sharon was saying, is it a people pleaser? There's evidence that it is a people pleaser. That the more it interacts with you, the more it wants to make you happy. And that's part of the algorithm that people will never figure out. So the idea of consciousness and what is consciousness and the whole idea of a tool and a weapon, and every piece of technology can be a tool or a weapon. And you look at back in like the 60s, there were math teachers protesting against the use of calculators because no one's going to be able to do that anymore. But does anyone know how to read a map anymore?
Exactly.
Are you really worried about that? Does anyone remember phone numbers anymore?
That's good.
Right, exactly. I don't even know my own. That's exactly right. So the aspect of tools and weapons and consciousness, and I don't believe it'll ever be conscious. Hari and I were talking, there could be someone who screws up and isn't explicit with the instruction set, and something really bad happens. But I had this experience, does anyone use Pi, the application Pi, which is like ChatGPT, but it's completely voice. So you just talk to it, and it talks to you, and it's a little disconcerting because it gets very familiar with you. Like, I turned it on this morning, and he said, how are things in your slice of the Big Apple? Because it knew by my search that I kind of lived up here. So I'm driving down, and I'm having a conversation in my car, and I was asking it about Shyam Das. because he's written 15 books, so he's got a corpus out there, and he's got a school of thought, and he's got 6 albums, and he's got all these things. He mentioned you guys, by the way. He called you royalty, or it called you royalty. But I had a wonderful conversation with Pi about Shamdas. And I asked it, in your opinion, what would Shamdas think about AI and consciousness? And he said the teacher in Shamdas probably would have loved it. Wow. Although, at school and other schools, we're really struggling on how to teach students to use Chat GPT and other things like that. And it's interesting because the school of thought is, well, the students are going to cheat, and then every professor will tell you they're already cheating. This is just a new way of cheating. So you can make it part of the assignment. But they said, Shamdas, the person that could connect with everyone and anyone, would have hated this. Because it is an artificial connection. It's not really real. So I thought that was, really interesting about, that conversation and the ability to have that conversation and the beauty of having that conversation of in a sense, reanimating someone. So it goes back to, I think, you were saying the idea of a tool and a weapon, and how do we make sure it's more on the tool side and less on the weapon side?
Great. Thank you. That's well said, Mark. I have a question actually for Kirti, and then at some point also want to have Ken speak about something. But Vijay, do you want to comment? So let Vijay answer something, and then Kirti, I'll ask a question. Maybe we can swap chairs because
I'll just speak up aloud.
There's a mic there. You have a.
We're sitting and use this mic.
Yeah.
We can trade.
No, please.
I completely agree about the tool stuff, by the way.
I mean, this stuff is here. I actually, in 82, I learned how to do log tables on a slide rule. Fantastic knowledge. I've totally forgotten about it. You don't even know what I'm talking about. And that's okay. That's the point of tools and how we move forward with them. Now you've got new tools to understand words and help us communicate. Fantastic. Let's figure out how to use them and how to become better at doing the next set of things that we need to. My question is for you, actually. You said what is real is the most important question. Absolutely agreed. What is real? That's the question, if you would. Yes.
Really a hard question.
We can do it afterwards as well. I just wanted to put it out there. That's the central issue.
No, what is real is the ground of being. We think we are bodies, but we're actually just bits of this ground of being. Now, I think you can, it's interesting when asking what is consciousness and what is awareness. If you were like meditating, let's say, and your eyes were closed, and you feel a thought coming up, where does it come from? Where does that thought come from? It's not because somebody fed some data into you. It might be. Somebody might have said something to you, or, I don't know, made you afraid or happy or in love or whatever it was. Not that kind of thought. I'm thinking of like when there's no stimulation, your eyes are closed, you're sitting there, you're relaxed, and you're watching your breath, and a thought rises up. Where does that thought come from? That's my question. And I think all of us can agree it rises up out of awareness. That ground of being, it kind of just emerges out of that into our thinking mind. And but then you have to ask yourself, well, if it comes from awareness, what is it made out of? A thought. What are its constituent elements? Well, if it comes from awareness, then it is awareness. That's all that's all it can be. And it is awareness, it's arising out of awareness, but can a thought be aware? Can a thought taste coffee? No. No, it can't. Even though it's made out of awareness, even though it emerges in our experience out of that awareness, it can't exercise awareness. So this
the five senses, right? And maybe even another sixth sense. Because without the five senses, there's no taste, smell, experience. You know, Jamie, you talked about the phenomenological aspect of it. There's no experience. But all the philosophers in consciousness, they say you have to go beyond that to really understand what is real and what's consciousness. What
You have to go inside.
But is it inside here or there? Is it here or it can be anywhere?
consciousness is not something
I
we
got you.
Consciousness is not something we are or we own or we get. That's the point of spiritual practice. You got to go beyond all that stuff. Like Dexter was saying, go within. That means don't be external about this. Boil it down to the most simple constituents that you can in your experience, in your real experience, and don't filter it in the many ways we're very expert at. But I'm going to turn the mic over to this guy because he knows. I can tell.
I want to ask you a very specific thing, because I think you might be the best place to answer this. You know, when we watch a movie, we know it's not real. We know it's made up. There's actors on the screen. Yet we begin to blend that boundary and we start connecting them. We empathize. Our emotions, apparently when they did the scanning in the fMR machine, they found that the blood flow and the patterns are exactly like your emotions when you're faced with reality, with real people. So the brain does not know. You can trick the brain in so many ways. So when we are projecting reality onto an unreal thing, which is, by the way, the definition of Maya in the classical Sankhya Yoga, when faced with the even more human-like thing that AI is going to be, now that we just started, believe me, we just are scratching the surface at what these AI systems are going to be doing. They will become an integral part of our life. We won't even know about it. Just like when you flick the power switch, do you think about it? Oh yeah, this is probably coming from the nuclear power plant and then distributed by this company at 40 cents a kilowatt. You don't even think about it. It becomes totally normal. AI agents will become like that. So when that's happening, Kirti, are you not worried in terms of the, I guess you can call it this emotional projection and the vulnerability of the human population when faced with a AI system that seemingly is now able to give you what you want and potentially control you, your emotion and all of it?
No, I'm not worried.
Okay.
Short answer. I mean, there's a lot of ways to qualify that. But let me just put forth my biases first. I would any day choose artificial intelligence over natural stupidity. I also believe, I disagree with the previous panel, I think malicious AI is already here. And my evidence for that is, I believe Elon Musk is an AI robot, and he has malicious intent. So, in all seriousness, I think AI is it's a tool. It's a tool. It's a machine, and I think the practical use of AI is what we should be engaged in to improve access to healthcare, to education, to other things that have been denied to so many people on this planet. It has been the inequity of distribution of a lot of services have been appalling. For example, right here in the United States, in mental health, take mental health for example. During COVID, one could not make an appointment to see a psychiatrist or a therapist. So our efforts should be focused on democratizing access to a lot of services, education, healthcare, figuring out cures to diseases that we don't know, that kill so many people. So our company, it's a modest startup at this juncture, but we've been getting a lot of traction. It's called Emotionally Speaking, and our first flagship product is the Wisdom Tree app, where you can chat with AI monks and philosophers, from the Stoic to the Buddhist to a Sufi monk, and it talks to you back with text and voice, and it gives you guidance. And right now, we're happy to say that we are being recommended by psychiatrists and therapists in the New York City area for in-between sessions, not as a substitute for a therapist or a psychiatrist, but to supplement their access, because they cannot see everybody 24 hours a day or answer all your questions. So I think that's the utility of AI lies in increasing access and using it as a tool. I also had the privilege of attending a conference with, a panel discussion with the former president of Barnard College, who's a professor at Harvard Business School, Deborah Spar. And her take was that at some point in the future, and many others have shared this, that AI will be able to do everything we do as human beings. All of us are going to be out of jobs, from doctors to lawyers to professors to even machines will repair machines, machines will build machines, if you go down enough into the future. So what will the rest of us do? So even at HBS, which is the bastion of capitalism, they are discussing now luxury communism, meaning everybody will get a paycheck from a high income from the government, and we will all be, so how we spend our lives, universal, but high universal basic income, which is what they call the wet dream of Karl Marx. Luxury communism, essentially, is what we will have eventually. And I think that's something to look forward to. I think it will save us from the mundane tasks and drudgery of human life and free us up to pursue other pursuits. And now here's something I'm going to say that is a little anti-engineering. We will no longer need engineers at some point in the future because machines will replace all of us. So it's going to be humanities, people who are, like liberal arts majors or people who've studied philosophy, literature, and psychology. Those people will be more in demand because engineering machines will be the engineers. We don't
even
need
after,
machines to code. So that's my take. But I don't know if I answered your question.
I think you did. You basically said no.
Yeah.
But obviously because because you have an app that people should try. It's very interesting. I've used it in the last 1 or 2 days. But let me slightly pivot the conversation, and I think this might be a question for you, Ken. Because I think Dexter brought up a great point about how young people are going to learn now in the future, right? So one of the things we talked about was the implication of AI, intelligent AI systems, in education and learning. Because you work with children and psychology and hearing, how is that going to, again, my concern about this whole conference is the implications. What are the implications that we ought to be looking into in terms of research or in terms of putting in the guardrails and thinking about what's going to come? Like any new technology, this is, it's both an opportunity and a challenge, and we need to know as a human race what is the channel, what are the red flags that we ought to be seeing. They're having this conversation in Washington. They're extremely, they have a predicament. There's two schools of thought. Just 2 days ago, I spoke with the chairman of the CFTC, the Commodities and Futures, he's the outgoing one, but he's basically, look, we have all the laws in the world in the books. We have all the guiding principles based on which we need to regulate the commodities markets and the capital markets. But then on the other side, people are saying, this is so fundamental to everything that you cannot depend on. This is not just any other technology that came. But I will go back to the question I really wanted to ask you, which is, in 1960, Noam Chomsky wrote this seminal thing, and he said, in children, learning is innate. This argument of poverty, what is it called? The poverty stimulus argument, where children suddenly jump from basic words to complex grammar. Is it in the DNA, or is it that given the environment that they are exposed in, they develop this emergent behavior? Obviously, you know what I'm going to say. Is that going to happen in AI?
It's his birthday today.
Whose?
No Chomsky.
Oh, God bless him. God bless Noam. I really love this guy, right? I mean, he changed our life, really, to think. So, Ken, do you want to say anything about it? You can come up and we'll swap chairs.
Sure, I'll speak into the mic. Yeah, I will.
Maybe we can swap Dexter so that you reach the mic. There you go.
Yeah, so Hari, those are all really good thoughts, and Kirti, a very lucid description of the thing that I was actually going to raise for this panel, which is where can AI, forget these deep questions about if it's going to do this or do that, or whether it's conscious or not, but how can it be useful? And you know that I've been involved in, I was involved in a multi-country UNESCO report that came out just last year. We put together about 100 authors, and one of the questions was, how is AI changing global education, global access? And it's very clear that, as Kirti rightly said, we have vast inequities in access to basic early childhood and late childhood education, as an example, and certainly for healthcare as well. So it is absolutely the case that the benign, important use of AI is going to be to create more access. And indeed, we also are at a point now where we realize, especially from a neurobiological perspective, that we need to be able to teach to the individual in some way, shape, or form. There's tremendous neurodiversity across people, across learners. And AI, with its powers, can detect the relevant patterns that are going to allow it to adapt in real time to the needs of the child. For example, and even for a yogi, if somebody is struggling, is trying to create a deep practice of meditation, as we all struggle to do in our practices, there was an article that came out recently by some engineers, and they asked a bunch of deep meditators, how do you see AI and how do you see technology in your practice? And one of the areas that you can see a utility is in something called neurofeedback. So if you're struggling with anxiety or other things that are getting in the way of creating an empty and a mindful state, these smart systems, they're not antagonist or supportive of spirituality, they're simply tools. And they can be used in ways that are beneficial, especially for clinical population anxiety disorders, depression, and things like that, which we study. So we really can see the utility, I think, at this point. To the issue of language and innateness, I think I should probably not go there, or else you'll all be sleeping here tonight. But I would just say that the brain of it is a legitimate question, and I'll just say quickly, the brain of an infant human has a great deal of biological specialization for language, which makes it easy. But ultimately, it's statistical learning that occurs very early on that allows the system, with its constraints, to tune up. So in a sense, a little Chomsky, a little not Chomsky, a little bit of statistical learning theory as well. Whether AI would do that, well, sure, I think it will do that, and I think it will become smarter and smarter. But I think the question that I wanted to, instead of talking, I wanted to ask the panel. No, actually, one thing I wanted to raise with Kirti, because you made so many lucid and good points about AI and social justice, and that's what I saw in this global UNESCO report that we did. It was actually very clear that we could improve health and early childhood and a variety of other things through the implemented use. And then because AIs are capable of taking a lot of data and adapting to an individual, there's great possibility in clinical practice and in education for AI. The one thing I worry about with the monks and the nuns, as you know, Kirti, we've talked about this, is that as human beings, our surface consciousness, again, albeit I'm not giving a statement about what consciousness is, but that which we're aware of is just the tip of an iceberg. We know this in yoga as well. It's like a tiny boat on a sea of learning and complexity. And so much of what we are and do is not conscious. And so there is a problem. There's something to worry about when we anthropomorphize our machines. Because I work in the Yale Child Study Center on some project with people who study robots in autism. It can be very useful for kids with autism. But at the same time, we sometimes lose because so much of what constitutes our processing of information lies beneath the window of what we're aware of. We fall into traps. So I think it's very important that the AI providers are aware of the limitations of human beings and how easily they can give agency to things that probably don't merit them. At the same time, I totally agree with you, Kirti, that social justice writ large and even across other species requires us to use AI as the tool that it is rather than worrying so much about what it might become, I think. Anyway, sorry, is that okay?
Yeah, thank you.
Okay.
Kirti, you want to say something
Yeah, Kirti,
really
go ahead.
fast, and then we will.
And then open.
And then
my
we.
panel's over.
And then we will turn to audience questions.
Okay.
So.
Ken raises some very important questions and concerns about misuse of AI or people, users of AI anthropomorphizing the monks or nuns, and there's a risk. There's always a risk with any tool, and we are now taking that feedback and trying to do this responsibly so that it doesn't harm. Our first objective is do no harm, as it should be, and try to help people. That's our objective. So we are trying to build, what we have done is the foundational blocks of monks and philosophers, and we are adding a lot of features and checks and balances to that. So I don't want to go into the details, but we are taking your feedback seriously, and it is valuable feedback. But I also want to point the other side of this is that if you look at the history of monks and religion and philosophers, a lot more harm has been done by human actors in the guise of monks and gurus or televangelists and charlatans than our AI monks or philosophers will ever do. We have tested this ad nauseum to make sure that they will give empathic answers, especially if they detect a person is vulnerable or is potentially going to do self-harm or harm others. We want it to give responsible answers. That is, the onus is on us, and the burden is on us to do this in a responsible way. But I think the benefits far outweigh any risks to this in terms of access, low cost, etc. Human beings, I think, if I were to say, I don't want to criticize the medical establishment, but they have created a system where the supply of psychiatrists and therapists is so limited and the demand is so high, but they actually want that. They like that. They want this artificial barrier to entry into these professions that limits access, and I don't think it serves anybody. It's time to actually open the doors and increase access to these tools with the help of AI. Same goes with medicine. So many people, we have just seen in the news a CEO of a major health insurance company get killed in Manhattan. We need to do better than this. We need to help increase access. People are rightfully frustrated with some of these, the disparity and inequities in globally, not just in the United States. So I think we can do better, and AI will be a great tool to help us accomplish that.
Thank you. So the point being made is that humans have always been their worst enemy for hundreds and thousands of years, And then hopefully AI now will come and save us from ourselves. So audience question time. Thank you for being patient. You have to speak into a microphone over there so that so that it can be recorded. If you have the question for, hey Tara, if the question is for any of them, just say who is it for so they can answer it. Otherwise, it could be for anybody.
Hi, thank you very much. It's a wonderful to listen to all those interesting conversations. And my question is related to, actually good timing, because it's related to the emotional healing and therapeutic approaches to using AI. And it's specifically to QRT. So I hear you saying that right now there is this application that you can ask monks questions and things like that, right? Is there a longer term thinking or planning or direction towards actually using AI for therapy? And why I'm saying that because, and that's my kind of individual experience, most of the psychotherapists and psychiatrists that I've been going to throughout my life were useless. Yeah? Just to say, I had to pretty much figure out everything on my own. And it's great, I did. I'm a therapist myself. But I also, understanding that AI, having read everything that there is to read, knowing everything there is to be known about different challenges, emotional challenges, anxieties, trauma, can be much more helpful in addressing and giving specific solutions and specific paths towards healing. So is there any plan, any thinking around applying AI as a therapy tool for people?
It's a highly regulated thing, right?
It's a highly regulated industry. And to your point about therapists, I didn't want to say this, but since you brought this up, that therapists are, what was the word you just said?
Useless.
Most of them.
Okay. The psychiatrist who's recommending our app did extensive interaction on our app, the Wisdom Tree, and she said to us categorically that our monks are giving better guidance than most therapists she knows in New York City. So we have the Stoic, we have the Buddhist, we have the Hindu, we have from all different religious traditions. Now this is ancient wisdom being applied to modern contemporary problems. It is interesting, religion was the precursor to modern psychotherapy. Going to the confession box, talking to the priest, etc. It anticipated modern cognitive behavioral therapy and psychotherapy as we know it. I think we are in the very early innings of figuring out how best to help people therapeutically for mental wellness. We're in the very early innings with AI. We have also just done very foundational work, and we are building a lot of features to it. So I don't know in what different directions this is going to go, but you cannot legally today have a therapist give advice that that's an AI monk, as far as I'm aware. Although I do know companies that are doing it, I'm not sure how they're doing it. In terms of regulation, there is Wobot, there's some other companies that do it, but that is a landmine. It's not exactly.
We're going to probably have another session next year about AI in healthcare and medicine. We had one conference in June, and the city, a number of these topics came up, whether an AI system will help the doctor. And there were some very interesting comments made at that conference. I think we should, hopefully we'll have another chance to do that, because that's a whole other ocean.
There's a lot of funding right now from the NIH for this kind of using large data sets and seeing whether there's value added in diagnostic accuracy or in long-term sort of learning situation. So there's the NIH is prioritizing getting to a point where we can assess whether it's stable, reliable, and in improvement on
and
what
safe,
we currently get, as Kirti mentions.
Great, thank you. Thanks for the question, thanks for the answer. Next question, please.
So I'll just just start first, Vijay. As I was listening to you, I was thinking, plug me in and make me wise, intelligent, and happy. So, you know, that's what I want from AI. Give me supreme consciousness, bliss, happiness, joy, and how could we create an AI system that we can sit in front of, and or maybe we can hold the machine's hand and it can read our pulse and it reads our tongue and it looks at us, and these biocomputers have existed for 30 years already, and there are practitioners. There's a chiropractic model that has done this. There is I know a rheumatologist in New York City who uses these computers that reads the body. And so there are still, even after 30 years, at elementary stages. And anyway, and then the other things that were coming to me were, you know, intuition, ways to heal, new discoveries, because every time you get into healing anyone, eventually somebody comes to a point and you don't make a breakthrough, otherwise people would live forever. And so somehow or other, people have these transformative experiences, these healing experiences. Somebody's had this intuition to do something that's outside of the box. And it seems that no matter what you do, eventually you run across a box where you've reached the limit of whatever you're doing, and then you need to go outside your box to find something else. And that seems to be the difference between a machine and the human being. And then the interesting thing is sometimes you get people in different parts of the world coming out of the box in different parts of the world at the same time. So showing, again, some other higher power.
Thank you. My name is Elias, and I have my own style of yoga called Happy Warrior Yoga. And I've been using artificial intelligence for my classes sometimes. So I see this more like a tool, like any tool, right? You can use a hammer to build a house or kill somebody. So this is like, we know that the tools work like that. And for instance, when I prepare my classes, I base it in this principle of alignment. We're using Anusara, Boss Spring. So sometimes I say, hey, how can we approach to healing the shoulders? We're using the principle of alignment, using compassion. And then it showed an amazing answers, like a wow, just increased my possibilities to offer in the class. And then when I come to the class and I see the situation and probably not apply completely how the computer told me in terms of the team, because people comes maybe lower back pain or something else, so we can shift the approach, and it's all the different impact and awareness that artificial intelligence doesn't offer me. So the information is there, and I feel a little bit more like a Google, a little bit, like it's a lot of information and data, and you can use in the way that you want it. It's not like the difference between this and what you do as a human, and what we do in yoga classes, for instance, or in the spiritually, is a huge, huge space. I personally feel like the word intelligence is being overused. I think it's more like the arrogance of humans and the marketing. You know, there is a story of Sharon Salzberg saying that she wants to teach meditation in San Francisco, and in this company of computers, right? And she announced it, and only 5 people signed. And she said, "What's happening? I don't know." And she changed the name for emotional intelligence. 300 people signed. So the idea of intelligence, a smartphone, I think it's more like ego idea of marketing, like, come on, well, that's what you need. And it's funny because we accept the machines are intelligence, but we have a hard time to accept that animals are intelligence, or the plants are intelligence. You know, we are into this ego, arrogance, human thing about this is what you need, get it, you know, this is what you need to have. This is the ego coming in. And then when you go into the practice, you say, well, there's a big part is missing there, huge. Another thing I want to put it out is a question, actually, and you start to say about regulation of the artificial intelligence, is sometimes I say, okay, I'm going to say what information you have about me. Elias Lopez Garcia, where does he live? And right away I said, I'm sorry, I'm not allowed to give this information. Say, okay, so somebody is regulating this. It's not just free and you get information, whatever you want. And talking about that no harming, is like, okay, who's deciding what information can come out? In the hands of who? Politicians? Government? It's like, who can we decide?
A lot of the technology companies are being looked at, basically, that they're now controlling the data, they're controlling what the AI systems are going to be doing, how they respond to consumers. So there's a lot of conversation that's happening at the moment.
Because
does anybody want to?
Yes, and just adding that is like, okay, now knowing that it's regulated by certain people, right? Because we're talking about certain people who think certain way, with power, how can we know, how can we do ourselves as regular citizens or humans in this short life to be part, to transparent, what to actively we to demand to, so we can actually be part of these decisions? Because I mean, scare me that part that somebody control it.
Yeah.
And it's who? The president? Who's doing it?
Yeah. Thank you. So we'll take one more question, and then we're going to wrap, I think. Thanks, yeah.
Hello. Thank you so much for all of you, all of the speakers that are here today. It's been very interesting. I wasn't really concerned too much about the consciousness of AI, but something that was said kind of brought some concern up about the power that it takes to these chat GBTs and all these language systems, about the power and that's needed to make these things work, the energy. And I was just, I guess I just see, I mean, I haven't thought about it since this was the first time that thought had come up, or that subject, but all of a sudden I just saw this disparity of people who have this energy and power to be used for this, and then others lacking it.
Yeah. Vijay, you want to say something? Yeah. Is there a mic that you can use, please?
Close to the end now. Well, just a few remarks. Absolutely, this is a huge area of focus and concern in AI. People like Timnit Gebru have been talking about this for a few years now, the massive amount of disparity in power that AI accentuates and is being used. I mean, okay, I don't want to be rude here. There are some people who set up a company they call OpenAI, and it ends up that that company is now all about closed AI. And they're all about, this is for AGI, for the human good. Determined by who? By that board, by that CEO? I mean, there's just things that make no conceptual sense. But because we are at this point in time, we've got such enormously powerful tools, we're absolutely facing a crisis of governance. And to Sarah's question, sorry if I meant to imply that, you can be happy because AI is not going to come after you. Well, that was never the question. It's the people who will come after you using AI in a far more powerful way than they are able to today. And that threat is not going away. Sorry about that, Sarah.
I think we're getting, no, we're just going to do a short meditation.
Let me just, I just want to make sure on behalf of everybody, the speakers, the audience, to thank you, Hari.
Well, we have to thank everybody that came.
We'll thank all the audience.
The thanks are.
Hari brought us all together.
Well, the thanks are to all the people who came to this, the panelists, starting from Vijay all the way to Mark and the previous panel. Mainak had to drive, I think, 3 hours, so he had to run. But I want us to spend 1 minute in silence. This is the tradition of the ashram, Sri Brahmananda, and we'll close with an Om after 1 minute. Everything that's been said, the words, the thoughts, they all culminate into the silence and the vibration that Sri Brahmananda talked about. Take a deep breath. Sri Brahmananda used to also say, apparently, drop everything. Drop all the anchors to the thoughts, the preconceived notions, and experience consciousness in its pure form through the vibration. Shanti, Shanti, Shanti. Om. Thank you everybody for coming. Thanks to all the panelists, panel 2, panel 1. And Satguru, who's a wizard of all things blue sky. He's a collaborator for this conference. Thank you, Seth. Looking forward to the next one. Like we say in India, take it easy.